Welcome back. We are on friction on an inclined plane, and we have a question in front of us that reads, a box of mass 6 kilograms is at a point of sliding down a rough plane, inclined at 30 degrees to the horizontal. What force, parallel to the plane, will just move the box up the plane? So if we should digest the information that we have, the motion is up the plane, right? Because it has been clearly stated here, what force parallel to the plane will just move the box up the plane. The body is in limiting equilibrium. Why? Because it says it's at a point of sliding down a plane. It is just about to slide down the plane. So in order to avoid that, a force is applied to move the body up the plane. Okay? So what will be the direction of friction? Friction is acting down the plane. Okay? These three information will be very important for us to draw our diagram. I know you could be confused about the direction of friction since you have read here that the body is at a point of sliding down the plane. Well, if at all the information has remained like that, friction would have acted up the plane, okay? But remember now that the motion is up the plane, okay? That is the final statement here, which is the most important. Since the body is moving up the plane, friction has to act in the opposite direction. So which means friction will act down the plane, okay? Moving on to draw our diagram. This is our diagram. The body has a mass of 6 kilograms. It's on a rough plane that is inclined at 30 degrees to the horizontal. The forces that we have parallel to the plane, we said one of them is mg sine theta. And since the body is moving up the plane, friction has to act in the opposite direction. Okay, so we're going to have friction acting down the plane. We want to find the magnitude of the applied force P that will just move the body up the plane. We have the normal reaction R that is perpendicular to the plane, and we have the weight of the body that is coming vertically downwards. So the body is in limiting equilibrium, and for a body that is in limiting equilibrium, the forces that are acting along the plane must balance each other. In other words, P must be equal to the downward forces, which are F and mg sine theta. So that will be P is equal to what? So what is F? F is mu R plus then mg sine theta. So we're going to have P is equal to mu. What is R? R is mg cos theta, then plus mg sine theta. So P will be equal to mu. We don't know mu, but we know that the body is in limiting equilibrium, and we've said that mu is equal to tan theta. We have proven that in our first video. So therefore, we're going to substitute tan theta in the place of mu. So we're going to have tan theta multiplied by mg cos theta, then plus mg sine theta. So that will be P is equal to, what is tan theta? We know that tan theta is equal to sine theta divided by cos theta, right? So we're going to substitute that. That will be sine theta over cos theta, then multiply by mg cos theta plus mg sine theta. So cos theta will cancel cos theta. P is equal to mg times sine theta will be mg sine theta. Then plus mg sine theta. So we will have 2 mg sine theta. That will be 2 times the mass of the object is 6 kilograms times 10 sine 30. So that will be 2 times 6 times 10 is 120. 120 sine 30. So that will be 60 newtons. We have another question in front of us that reads, a box of mass 6 kilograms is at a point of sliding down a rough plane inclined at an angle theta to the horizontal. The coefficient of friction between the box and the plane is 0.42. Calculate the angle of inclination of the box at which it begins to slide down the plane. So the information that we have is that the body is in limiting equilibrium. Because it is at a point of sliding down a rough plane. Okay, it is just about to move. So the motion is down the plane. Okay, and there is no applied force. So this is the diagram that we have. The mass of the body is 6 kilograms. All right, that is resting on a rough plane, inclined at an angle theta to the horizontal. And in fact, the question wants us to determine the value of theta. So if we should indicate the forces that we have associated with this diagram, we have a force that is always acting downwards, which is mg sine theta. And since the body is sliding down the plane with no applied force, we're going to have friction that is going to act in the other direction, that is up the plane. Now we can indicate the normal reaction and the weight. That is the normal reaction R, and we'll have the weight acting vertically downwards. So since the body is in limiting equilibrium, it means that the forces that we have parallel to the plane must balance each other. So that is to say, F will be equal to mg sine theta. Okay, but what is F? F is mu R. So this is equal to mg sine theta. That is going to be mu. What is R? R is mg cos theta. So this is equal to mg sine theta. We can now divide both sides by mg cos theta. So this will cancel this. That is mu is equal to mg sine theta all over mg cos theta. So mg can cancel mg. We will have mu is equal to sine theta over cos theta. So what is sine theta over cos theta? That is going to be tan theta. Okay. Now the question wants us to find the value of angle theta, and we know that for a body that is in limiting equilibrium, using mu is equal to tan theta, we can be able to determine that angle. Okay, so the coefficient of friction is 0.42. This is equal to tan theta. We can say tan theta is equal to 0.42. So to find theta, that will be the tan inverse of 0.42. And if you use your calculator and bring in the second function of your tan key, that is tan inverse of 0.42, will give you 22.8 degrees. We have another question in front of us that reads, a box of mass 5 kilograms rests on a rough plane inclined at 30 degrees to the horizontal. What is the frictional force if the box does not slide, if the box slides with an acceleration of 2.4 meters per second square? So we need to find the frictional force in two different cases. Now for the first case, let's try to bring the diagram and we explain it. So this is the diagram. The mass of the body is 5 kilograms. That is resting on a rough plane inclined at 30 degrees to the horizontal. If we should indicate the forces that we have, one of the force is acting downwards, which is mg sine theta. Okay? And the information that we have is that it wants us to find the frictional force if the box does not slide and if the box slides with an acceleration, which is the second question. Now for the first case, if there is no external force, the mg sine theta tends to be the force that will cause the object to slide down the plane. So to avoid it from sliding down the plane, a force is needed to act in the opposite direction, and that has to be the frictional force. So the frictional force has to act in the opposite direction so that the body does not slide and it remains at rest. Now we can indicate the normal reaction, R, and the weight. So for the first case, the body is in limiting equilibrium. Okay, so remember there is no motion. Okay, we wanted to know the force that has to balance the force that is going to cause the object to slide. Okay, so which is the frictional force. So which means the frictional force is equal to mg sine theta. And what is the mass of the object is 5 multiplied by gravity is 10 sine of 30 degrees. So that will be 50 sine 30. And what is 50 sine 30? That is 25 newtons. Okay. So the frictional force that is needed to prevent the object from sliding is 25 newtons. Now moving on to the second question, where there is an acceleration of 2.4 meters per second. We have a body of mass 5 kilograms and it is on a rough plane inclined at 30 degrees to the horizontal. but it is going to accelerate at 2.4 meters per second squared. Okay, so it is going to slide down the plane. So now let's complete indicating our forces that are involved. We have a force that is going to act downwards, which is mg sine theta, and the force that is going to oppose this is going to be the frictional force. So it's going to act in the opposite direction if the object is to move down. We can indicate our normal reaction R and the weight. So the body is in acceleration. If a body is in acceleration, there has to be a net force. So if it is to accelerate down the plane, it means that mg sine theta must be greater than the frictional force, okay, to create a net force. So net force, we know that from Newton's second law, is equal to ma. So what will give the net force? That will be mg sine theta minus the frictional force. This will be equal to ma. All right, so we want to find F. Remember that. So we're going to have mg sine theta minus ma is equal to F. Okay, so therefore, the frictional force is equal to mg sine theta minus ma. If we substitute the values, the mass is 5 multiplied by gravity is 10. Sine 30 minus the mass is 5 multiplied by acceleration is 2.4. So that will be 50 sine 30 minus 5 times 2.4 is 12. So 50 sine 30 is 25 minus 12. And what is that? 25 minus 12 is 13 newtons. So the frictional force has to be 13 newtons. We have another question here that reads, a box of mass 9 kilograms rests on a rough plane inclined at 30 degrees to the horizontal. What is the coefficient of friction between the box and the plane, the frictional force, and the normal reaction if the box is in limiting equilibrium? So let's bring in the diagram. This is the diagram. The mass of the box is 9 kilograms that is resting on a rough plane inclined at an angle of 30 degrees to the horizontal. The information that we have here is that the box is in limiting equilibrium, and if we should provide the forces there, we will have mg sine theta acting down the plane, and if the body is about to slide, so friction has to be in the opposite direction, that is F. Completing the diagram with the normal reaction and the weight, we will have a diagram that looks like this. So we want to know the coefficient of friction, the frictional force, and the normal reaction. Okay? The coefficient of friction, the frictional force, and the normal reaction. That is what we want to find. We have already proven that for a body that is in limiting equilibrium, the coefficient of friction is equal to tan theta. Okay? We have shown how to derive that in our previous example. You can check. So if mu is equal to tan theta, which means the coefficient of friction will be tan of 30 degrees. So what is tan 30? That is 0.58. Okay, that is the coefficient of friction. We also want to find the frictional force. So in this diagram, the frictional force can be equal to mg sine theta, okay? Because the forces have to balance each other if the body is in limiting equilibrium. So that is to say, F is equal to mg sine theta. So that will be, the mass is 9 multiplied by gravity is 10 sine 30. That is 90 sine 30. And 90 sine 30 is 45 newtons. To find the normal reaction, we know that the normal reaction is mg cos theta. So that will be, the mass is 9 multiplied by 10 cos of 30. So that is 90 cos 30. And 90 cos 30 is 77.9 newtons. So that is the normal reaction. But you know that mu is also equal to F all over R. So if you divide the frictional force with the normal reaction, you should have 0.58. Okay, that is 45 divided by 77.9. You will have 0.58. We have another question here that reads, a box of mass 9 kilograms is at a point of sliding down a rough plane inclined at 30 degrees to the horizontal. The coefficient of friction between the box and the plane is 0.3. What force parallel to the plane will just move the box up the plane? Okay, so we have motion up the plane. That is clear from the statement, what force parallel to the plane will move the box up the plane. So that is the direction of motion. We know that the body is in limiting equilibrium. For the fact that the body was about to slide down, okay, the plane. So which means here we need to know that the friction will act down the plane. The reason for that is the body is moving up. Do not be confused from the statement that the body is at a point of sliding down the plane. What you have to consider is the statement that we have here, the direction of the applied force. So the force is applied upwards in order to move the body up the plane. So it means the friction have to act in the opposite direction, that is down the plane. Now let's try to draw the diagram. This is our diagram. The mass of the body is 9 kilograms. That is resting on a rough plane inclined at 30 degrees to the horizontal. The coefficient of friction is given as 0.3. So if we should indicate the forces that we have a force that is going to act downwards, which is mg sine theta. And we're going to have the frictional force that is also going to act downwards. Okay. So they want us to find the force that is going to move the object up the plane. Okay, remember the body is in limiting equilibrium. And if it is in limiting equilibrium, it means that P must be equal to F plus mg sine theta. So, but what is F? F is mu r, then plus mg sine theta. So that will be mu, what is r? R is mg cos theta, then plus mg sine theta. So what is mu given in the question? It is 0.3 multiplied by the mass of the object is 9, gravity is 10, cos 30 plus the mass of the object is 9 kilograms multiplied by 10 sine 30. So 0.3 times 9 times 10 is 27. So that will be 27 cos 30 plus 9 times 10 is 90. That will be 90 sine 30. So what is 27 cos 30? 27 cos 30 is 23.4, okay, plus what is 90 sine 30? 90 sine 30 is 45. So that will be 23.4 plus 45. We're going to have 68.4 newtons. We have a question in front of us that reads, a box of mass 8 kilograms is on a rough plane inclined at 30 degrees to the horizontal. The coefficient of friction between the box and the plane is 0.6. An applied force of 96 newtons parallel to the plane moves the box up the plane. Determine the acceleration of the box. So if we should break down this information, the motion is up the plane and the body is in acceleration. So there is also an application of an applied force. Okay, applied force is present. So if we should draw the diagram for this, this is the diagram. Let's try to indicate the forces that are associated with this diagram. We have a force acting downwards, which is mg sine theta. So since the body is moving upwards, it means friction have to act downwards. Okay, there is an applied force of 96 newtons. Okay, that is the magnitude of the applied force that moves the body up the plane. Okay, and the body was in acceleration. We want to determine the magnitude of the acceleration. We can complete the diagram by indicating the normal reaction R. The mass of the object is 8 kilograms, and we can indicate the weight that is acting vertically downwards. We have an angle of inclination of 30 degrees. So that is the diagram. Now we know that if there is an acceleration, there has to be a net force. So the net force is equal to MA. So what will give the net force? It will be the applied force minus the sum of the downward forces, which are F and mg sine theta. So this is equal to MA. So that will be P minus, what is F? F is mu R, then plus mg sine theta. This is equal to MA. So that will be P minus mu, what is R? R is mg cos theta, then plus mg sine theta. This is equal to MA. I think we can now substitute, okay, the values. Mu is 0.6. The applied force is 96. So the applied force is 96 minus mu is 0.6 multiplied by the mass of the body is 8 kilograms multiplied by 10 cos 30 plus the mass of the body is 8 kilograms multiplied by 10 sine 30. This is equal to mass of the object is 8 multiplied by the acceleration. So we're going to have 96 minus 0.6 times 8 times 10. That will be 48. So we'll have 48 cos 30 plus 8 times 10 is 80. So that will be 80 sine 30. This is equal to 8A. So that is going to be 96 minus 48 cos 30 is 41.6. Then plus 80 sine 30 is 40. This is equal to 8a. So we're going to have 96 minus 41.6 plus 40 is 81.6. This is equal to 8a. So 96 minus 81.6 is 14.4. This is equal to 8a. To find a, you divide both sides by 8. So therefore, the acceleration will be 1.8 meters per second squared. Another question here that reads, a box of mass 12 kilograms rests on a rough plane inclined at 30 degrees to the horizontal. The frictional force on the box is 20 newtons. Determine the least force needed to move it up the plane. The second question is to prevent it from sliding down the plane. We have the friction of 20 newtons. The body is inclined at 30 degrees and the mass is 12. So let's first try to analyze the first situation. So we want to find the applied force needed to move the box up the plane. Okay, the first one is the box is going to move up the plane. So if this is the diagram and the box is to move up the plane, it means the applied force is acting upwards. They want us to find that. So it means that the friction has to act in the opposite direction. So let's indicate the downward forces. One of them is always acting downwards, which is mg sine theta. And the other one is the frictional force that will act downwards because the body is to move up the plane. The mass is 12 kilograms. And if we should indicate the remaining forces, we have the normal reaction R and we have the weight. Remember, it is inclined at 30 degrees to the horizontal. So if we have to determine the least force needed to move the object up the plane, acceleration has not been mentioned here, so we are dealing with limiting equilibrium. In that case, it means that P must be equal to F plus mg sine theta. So the friction is already given in the question as 20 newtons. So that will be 20 plus the mass is 12 multiplied by 10 sine 30. So that will be 20 plus 120 sine 30. And that will be 20 plus 120 sine 30 is 60. So that will be 80 newtons. We have answered the first question. The second question is we want to determine the least force needed to prevent the body from sliding down the plane. Okay, so the second question, the object is to slide down the plane. So if it is to slide down the plane, it means that the force that we need to prevent it from sliding down the plane has to act upwards. Does that make sense? So the force have to act upwards. Okay, the force that will always act downward is mg sine theta. So the body is going to slide downwards. So if it is going to slide downwards, it means that friction also has to act upwards. Okay? Friction also has to act upwards. The mass is 12 kilograms. The angle of inclination is 30 degrees to the horizontal. The normal reaction is indicated here as R. And we have the weight, W. We are still dealing with limiting equilibrium. We have the body of mass 12 kilograms resting on a rough plane. They want us to find the magnitude of P, that is the applied force needed to prevent the body from sliding down the plane. If the body is to slide down the plane, that is motion down the plane, it means friction have to be in the opposite direction. So friction and applied force are in the same direction. That is, we can say P plus F must be equal to mg sine theta. So that will be P is equal to mg sine theta minus F. So that will be the mass is 12 times gravity is 10 sine 30 minus the friction is given in the question as 20 newtons. So that will be 120 sine 30 minus 20, and 120 sine 30 is 60 minus 20. 60 minus 20 will be 40 newtons. Okay? That answers the question. A body of mass 7 kilograms rests on a rough plane inclined at 30 degrees to the horizontal. The coefficient of friction between the body and the plane is 0.3. If the body moves down the plane from rest, determine the acceleration of the body. So to break down the information, the motion is down the plane. The body is in acceleration. Okay? And we have no external applied force. So if we should draw the diagram, this is going to be our diagram. We have a body of mass 7 kilograms that is resting on a rough plane inclined at 30 degrees to the horizontal. Now, if we should indicate the forces that are associated with this body, we will have mg sine theta acting down the plane. We are informed that the body is accelerating down the plane. So it means the friction has to act in the opposite direction. Now we can indicate the normal reaction and the weight. So that is the normal reaction and that is the weight. So what is the coefficient of friction? It is 0.3. Remember, the motion is down the plane. So if there is motion down the plane, it means that mg sine theta should be greater than the frictional force for the body to be able to move down the plane with acceleration. So there is a net force. We can say net force is equal to ma. That is to say mg sine theta minus the frictional force is equal to ma. So that will be mg sine theta minus the friction is mu r. This is equal to ma. So that will be mg sine theta minus mu. What is r? R is mg cos theta. This is equal to ma. If I want, I can factorize m out. So that will be m into g sine theta minus mu g cos theta. This is equal to ma. So m will cancel m. So g sine theta minus mu g cos theta is equal to a. So therefore, we can say a is equal to g sine theta minus mu g cos theta. That is, a is equal to g is 10 sine 30 minus the coefficient of friction in the question is 0.3 multiplied by g is 10 cos 30. So a is equal to 10 sine 30 is 5 minus 0.3 times 10 is 3. So what is 3 cos 30? 3 cos 30 is 2.6. So therefore, acceleration is equal to 5 minus 2.6, which gives 2.4 meters per second squared as the acceleration. Thank you very much for watching this video. If this is the first time of visiting this channel, please subscribe to the channel, like our videos, and you can share them.